Hey guys, thanks for tuning in. Today we're going to build and do our first prints on the brand new Creality CR-10 Smart Pro. But make sure you watch the whole video because there are some gotchas and there are a couple small issues. All right, after it's unboxed, these are all the parts that we have. This is a direct drive 300 by 300 by 400 printer with a lot of neat features, add-ons, and internet connectivity. I've read through the product literature thus far, and I'm curious to actually get my hands on it. So looking at some of the pieces here, we have a touchscreen with the plastic on it. Should have left that on until it was assembled. Now it's going to get scratched for sure. This is a capacitive touchscreen, I believe. It's not resistive. Feels nice. In this little bag, we have, all right, we've got the camera, which they call an AIoT camera. So it's a artificial Internet of Things or a artificial intelligence of things. Anyway, that's what the literature said. Anyway. We've got a webcam, essentially, and there's a little tripod stand for that camera as well. Would be nice if the camera actually affixes to the frame somewhere. And obviously, we have 3D printers, so we can always print that option for ourselves. We've got a sharpened scraper, the little filament spool, which I won't use as usual. Nuts and bolts, power cord, spool holder, kind of similar design to some of the others where it's just turn and twist with the addition of a bearing, or at least it's just sleeved on there. Either way, this rolls extremely freely, where most of the other ones, the spool is just kind of dragging along the plastic, right? That's kind of nice. The smoother your spool rolls, the less resistance there is. And we've got the filament runout sensor. It's got a fingerprint on it with an arrow. That's interesting. I'll leave that on for now. So, filament runout sensor up top there. And we have 2 support braces. These are very similar to the Creality support braces we've seen in the past where they screw together. They come pre-assembled like this. And then you adjust the little eye bolts on the end to the perfect length to make sure that they're keeping the upright gantry nice and stiff. So this is kind of typical install we've seen many times. We'll take the gantry here. There's little cutouts in the sheet metal of the base here. Make sure we're not pinching any wires. There we go. So that will sit generally like that. And then and we've got these long M5 bolts. These ones right here, 4 of these. There's going to be 2 in each side. They've got lock washers on them as well. And so I'll just slide this to the edge of the table and bolt in from underneath on both sides, and then we'll come back. So right as I went to bolt this in, I realized I might have left something in the package. I was looking for the assembly tools, and they're in the front of the printer. So open that up, take a look in there. There's a lot of goodies, actually. Inside here, we have the SD card, and on the front of the printer, there's even a little sticker that shows you which way that goes. We have this little needle for cleaning out a clogged nozzle, or in my case, stabbing yourself in the finger. And then there's 2 spare nozzles. The literature says they're chromium vanadium, so they should be wear resistant. There's the SD and micro SD to USB adapter. And then we have a wrench and a little socket. There's also a tiny pair of flush cutters, little small for my liking. I like the bigger blue ones, but it's kind of nice that they, stuck. Kind of nice that they fit in here, anyway. So now we're going to install the hot end and extruder assembly. You know, it's direct drive, all in one, to the X carriage up here. This looks kind of similar to a lot of the other Creality X carriages. except with this added little bracket on the side. You need 3 M3 by 6mm screws, and I was looking for those screws initially, and they're actually threaded into these 3 holes on the side that will go through this side plate there. On the back, there's a circuit board. So like a lot of hot ends we've seen lately, they kind of have a daughter circuit board up here, and everything on the hot end assembly plugs into that, and then it just makes for a clean kind of single grouped connection back to the board. So there's 2 little divots there where these standoffs will kind of just sit in those places. And so then we'll bolt through the side, as I mentioned. There, so I've got it mounted up, 1, 2, 3 bolts there. This bolt was pre-connected to here. We didn't remove that one. It's nice and secure. That's going nowhere for sure. It's an interesting design. So looking at it from the front, you'd think, where's the fan blowing through the heatsink to keep the cold side cold? I'm worried about heat creep. So the heatsink is actually back here, and this fan here points through to the nozzle. So this is the part cooling fan. So on the other side, we have another fan here behind this little cage so we don't get our fingers. And this is blowing through a duct, through that heatsink and out the other side. A couple things that I like about that, the performance of it is yet to be seen. A couple things I like though, especially if I'm printing ABS or something, I don't want any air blowing on my print. And some of those through the front heatsink designs dissipate a lot of air kind of down towards the rear of the machine. That's less than ideal in that particular situation. This should exhaust it straight out the side, and there's no vents on the bottom, so it shouldn't blow on your print inadvertently. But it does make for a very nice compact package. Yeah. They also, I should mention, like the parts that matter, it's all metal. I know that the literature also says it's all metal, but even like the extruder lever gear, this is metal with nice spring tension. Creality branded BL Touch clone. Yeah, like the clone. And it's got a metal probe pin, and it's very thin. We've got a silicone sock on the hot end there, and we've got one of those nozzles pre-installed. It is using the relatively small 4010 part cooling fan. They don't tend to move a ton of air, and in this particular setup, we've got air blowing from the front, which leaves the back side less adequately cooled. So if you are printing towards the front, the filament that's coming out the back is not really getting cooled the same way that if you were printing front to back, the moment it exits the nozzle, it's being cooled immediately. So having at least 2 sides gives you better coverage, at least 50% coverage, if not more. One side's going to leave this back, not lacking, but ripe for improvement. Let's say that. All right. So while I'm here, I'm just going to check the rollers. They're rolling nice and true. There's no indent kind of feeling sections or flat spots or anything like that. And obviously there's no slop in any of this. It's nice and rigid. That is a very compact arrangement for sure. So because I was excited to get the hot end attached there, I kind of skipped a step. But the second step was actually to attach these braces. So the braces here are going to get attached to the bottom rear of the case and to these little ears off the top here. To do so, we're going to use some M5 bolts here. They're M5 by 12s and by 20s. The shorter of the two go up top, and the longer ones go at the bottom with a washer. And the washer is between the eye bolt here and the case. So just you're protecting the case essentially. Really what you're doing is you're clearing this gap of this little top lip on the case. It sticks out just a little bit, so the washer just spaces that out. So we'll do this side first, I guess. So I've got the longer of the two, the M5 by 20, throw a washer in there. And I'm not gonna tighten this down fully because while it's loose like this, I can kind of spin things and still get my hand in there nice and easy to tighten that. Because by twisting the rod, I can lengthen it or I can shorten the rod. And then when I've got it the right length, I would lock it in by tightening against it with the nut there like that. Obviously using the wrench that's supplied. And so like that, we'll extend this one a little bit too. go. So that looks maybe a little bit longer. So I'm extending each side equally kind of too, just because I like it to be symmetrical. There we go. And then we'll throw one of the shorter bolts through here. There. All right, so we've got these connected. When you're installing these, you know, when you're lengthening those eye bolts, I just kind of kept both sides equal. You don't want to be putting pressure like upwards or pressure downwards on this. You know, this should be perfectly perpendicular to the base. So all we're trying to do is make it line up so that we can put the screws in with no pressure either direction and then tighten everything down good and tight. So now that will really help keep this stable and you won't have that kind of wobble as the bed moves back and forth. Since we're looking at the back here, the bed has a beefy cable coming out of the back with very good strain relief. It is a thick cable. You know, it was a little bit smashed when it was in the box. And of course, I'm rolling over these cords here, so you gotta be careful. So it is a thick cable with strain relief, which is nice. We also have the cords that I mentioned. So we may as well connect these now. I'm not sure what step that is in the guide there, but if we slide the bed forward and you move the bed slowly, if you're moving it manually, you don't wanna put like back EMF through the wires. So we have the cable labeled Z1. Obviously this goes in the motor here. Dual Z, if you haven't noticed. And the dual Z is actually attached at the top up here with the timing belt. So even if you just move one of these, they're both going to move thanks to the belt up top. So you don't have to worry about your X getting kind of out of kilter like that. And this top belt here doesn't have to be tight. Like the tension on this doesn't matter. As long as the teeth are engaged into the gears on either side, that's more than tight enough. All right, the other connectors, they are color-coded. Not labeled, but they're color-coded. So we've got the multicolor one, and then we've just got a black and two black. There we go. And all of those cables are, you know, keyed. They only go in one direction, and I'm just going to tuck them into the case. They were originally taped down with black tape, so we'll just remove that. On this side, we only have the Z stepper motor cable to connect. Okay. So we've also got this ribbon cable. Now this ribbon cable is going to go up to the hot end here, and it's got, you know, multiple wires inside that ribbon to support all the different bits up there. Coming out of the side, we've got two more connectors, and that's going to be for something over here. There we go. Yep. So that's the X limit switch, which is under this shroud on this side, and for the X-axis stepper motor, which is right back here somewhere. Anywhere? Yeah, right there. So on this cable, there's this little label in a little bit of broken English, and it's essentially showing you that this goes into something. And what I gathered from that is they're referring to this going into the little claw thing here, like that, I guess. And then those two cables for the X-axis stepper motor and the limit switch, we'll just connect those now also. You know, as I was flipping this around, I was thinking a few things. Number one, it's got nice soft rubber feet on it. Super grippy, it's not gonna slide around the desk. It's also very heavy, and the base is feels very solid. Some of the other printers that I've had in the past, especially in this size, when they have enclosed bases like this, they feel very tinny and cheap. This feels like a tank, basically. Not that it's going to take a lot of abuse, but it feels and looks nice. So the rest of the ribbon here needs to go to the hot end. This little bar here seems to clamp down the cable, so we're going to remove that bar, and then it'll plug into the socket that's right underneath there. But before I do that, I'm just going to double check the manual, because I have gone completely out of whack as far as the sequence of steps goes, and just make sure I'm not forgetting anything. Yeah, I missed a bunch of steps, but luckily the order in which they occur isn't super important. And you know, when I unpackaged it and I was looking at how nice and smooth this thing spun, I attached it to the spool holder. I've now detached it because, of course, I attached it to the wrong side. So it gets attached to the same side as the filament runout sensor there, like that. And then there are, I don't know if you can see them, there's two little fingers on this piece, and there's two fingers here. There's two fingers on the front piece, and there's two fingers on the top piece here. And those fingers lock into the top groove here, and these little grooves right across the front. So if you lean it forward, they'll lock into those front grooves, and then you're just gonna pull it backwards and it'll latch in. I would just wanna make sure that my spool is gonna be kind of centered in the middle of the machine, somewhere around there. Looks probably pretty good. And then push down, there we go. So this little pigtail wire here is gonna plug into the filament runout sensor, and the filament runout sensor, because of the arrow, needs to go in this direction. Now I don't have a lot of slack here. This wire is just held into this top 2020 rail with a little plastic insert, and if you slide the plastic insert all the way to that side, it then gives me much more slack. So attach that like that, and then I'll just slide that insert back just to kind of take up the extra little slack there. There we go. And so our spool is gonna spool in an overhand kind of fashion, go through here, and then go straight down into the extruder. The other step that I had skipped over is the screen. So the screen, you know, if you picture it sitting on the ground like that, that's the direction it's gonna get installed. And it's just got these little keyholes in the back, and we've got these pre-installed screws on these little studs there. It's just gonna slide onto that. Before we slide it on, of course, we're gonna have to put the cable through here. And like all the rest of them, it only goes in one way. Just make sure that's fully in there. And then we'll essentially feed that cable back into the machine, rest it on the little screws, and then just press down. So the next step, it tells us to plug in the power, but I figured before we did, since we're here, we'll take a look at the ports on the side. So the webcam that we saw earlier, that's gonna plug in here with a USB-A. And we have a USB-C port for communication with the printer, which is, I think, the first time I've seen a C port on a Creality machine. We also have a RJ45 for Ethernet, so for hardwired networking. There is also Wi-Fi and Bluetooth on board on this machine. And we have a power button with a label here that I haven't taken off yet, but it tells us that the power button, you hold it in for 3 seconds to turn on the machine. You hold it in for 30 seconds for a firmware flashing mode, but it is not for powering off the machine. So it'll be interesting what the supported power off approach is. I would suspect that it's through the screen itself. We also have very large manual leveling knobs. They are an anodized aluminum, red anodized aluminum. They feel nice, they're grippy, and they're easy to reach. So, you know, those smaller knobs kind of suck, but we've seen large knobs for quite some time now on printers. Both the knobs in the front are also anodized aluminum. You have the Y-axis tensioner for the belt. And on both the X and Y, they're using genuine Gates power grip belts. Up here on the X-axis, we also have the X-axis tensioner, again, aluminum. And you know, I didn't really pay much attention to it earlier on, but we have a light bar, an LED light bar here with its own on-off switch on the top. We're not plugged in, so it's not turning on, but that'll be nice. You can illuminate the printer, especially if you're using the webcam. Maybe it's in a dark room. You can just leave that on so you can still see the print going. So with all that said, let's get this thing plugged in and at least powered on. All right. So the last thing we have to do before we're going to power it on is hook up this cable to here. But before I do that, I was just lowering the X-axis, or sorry, the Z-axis to bring the X-rail down. And I noticed on the back here, the wire for the LED light bar is rubbing up against the lead screw. So again, there's just plastic shroud that kind of holds all the wiring in the extrusion. I'm just going to try to pull a little bit of wire down through the bottom here. There, that's all I needed. Just like a centimeter or so. And make sure that it's not hitting the leveling knob either. And before I forget, you know, it feels good, but just checking the wheels on the bed, make sure that they're all making good contact and not slipping around. There's definitely no slop in the bed, that's for sure. So we're ready to plug in the power. When I was installing the screen, and this goes for basically anything on a printer, to be honest, you shouldn't unplug and plug it back in when the power's on, right? So specifically on the screen, it warns you about that. You know, unplugging and plugging stepper motors when they're energized is not a good idea either. So just, you know, if you're doing any kind of maintenance related to unplugging things, just turn off the power. All right, so this little bar here, we're gonna unscrew the two using the right size Allen key. We'll get these two bolts out of there. So that bar is gonna act like a form of strain relief. And then this guy, yep, he's keyed, it's got a little notch in it. So that goes towards the back. And you open these fingers, slide this in. Like that. If you push it down all the way, they should just snap themselves in like that. And then as extra precaution, this guy here. All right, now we can plug it in. All right, moment of truth. Nothing, as expected. So remember, we saw this little label that says we got to hold in the power button for 3 seconds. So let's try that. I feel much better. So the BL Touch did its normal click click on power on. It's a lot quieter. Not that the noise of a BL Touch is much to be concerned about, but it's quiet. And they're also using, yep, looks like they're using, you know, temperature sensitive fan control. So the hot end doesn't need to be cooled right now, so none of the fans are going. And there's a very quiet fan inside the case here somewhere. So it definitely is a capacitive touchscreen. We're on the home menu right now. We've got the, you know, the hot end, the bed temperature, etc., speed. This looks like Z offset minus 0.05. Well, we haven't homed it, so it has no idea where it is. So let's go into, oh, and we've got a little Wi-Fi symbol here. No, it's probably under settings. All right, in settings, got a bunch of stuff. Leveling options, language, power off as expected, so that you control the power of the machine through the screen. Light control. So you've got both hardware control and software control of the light. I'm curious if that light would be controllable through G-code, which I've seen on some Clipper firmwares, for example. That's cool, yeah. I mean, it likely is G-code at that point. Usually the screen's just sending G-code commands. So we've got PLA settings and ABS settings, probably the two most commonly used materials. So you've got nozzle temperature and heated bed temperature. They've listed it as H and B, like H ampersand B temperature, but you get what they're getting at. Let's turn that. That's cool. So PLA and ABS settings, they're probably just the same thing. Yep, just the kind of the preheat temperatures for them. If we go into advanced settings, we've got restore network, restore all, movement, temp PID, so your PID tuning options are in there, Wi-Fi, and run out sensor. So you can disable the run out sensor if you weren't using it, or if you had a problem with yours or something. I'm curious where we go into like the Wi-Fi settings though to set this up. Let's maybe go into advanced settings. I have a sneaking suspicion we're gonna have to do a bunch of this through the app. I'm gonna spend the next 5 to 6 days playing with this printer. I'll learn how to configure things like the Wi-Fi. I know that there's an app component, which we've seen their app briefly with their cloud connected box, their kind of Raspberry Pi equivalent, if you will. So I'm curious if it's the same software or different. I'm also going to get the webcam up and running, and I'll do a few prints. I think one of my first prints will probably be some sort of a mount for this. It uses a standard threaded bottom like any of these tripod mounts would use. So that means that any mount that is currently compatible with that, I'd be able to use. It's a question of where I'm going to attach it to the printer, whether I attach it like off the side here with an arm or something, I don't know, some weird top-down approach, or even something up in the front here. So we'll have to play with that, but that'll give me something to at least occupy myself while I learn the ins and outs of the machine. A few things that I didn't mention, of course we've got a we've got a spring steel PEI powder-coated spring steel print surface. I much prefer the powder-coated PEI, number one, from a longevity perspective, especially if you're printing at high temperatures. You don't have kind of the bubbling effect that the adhesive on a PEI sheet would have. The downside, or another positive, if you will, is, depending on your perspective, is that all your prints are going to have a textured bottom surface. So if you're going for something with a gloss, this is not going to work for you. Another thing worth mentioning is that I noticed that the magnetic adhesion is it's a pretty strong magnet, let's put it that way. You can also get access to the screws that lead through the leveling knobs because they're cut out in the magnet. And the magnet actually has these curved, it's not just the magnet, the heated bed actually has these two curved kind of cutout sections. I'm not sure of the purpose of those. The one thing that I could think is if you didn't have this little pull tab, you could use that as a pull tab on the side, but this sheet happens to have this little front tab. Some sheets, yeah, they don't have, either they don't have a tab at all or they don't have a big one, so then you could use these as a point to grab. And it's also nice that they've got these notches with the little screws at the back, just to kind of get the alignment right. If you're trying to blind align a mat, it can be a little bit cumbersome. On an open printer like this, not usually as big of a problem because you can easily see all the edges of the mat to make sure that it's on there centered and squared. So with all that said, I'm going to leave you and we'll come back with some prints and we'll run through all of these software options and I'll have some conclusions. I printed, and before we get to the prints, I have some comments. I actually made myself notes this time as I went through the process. So the first thing the manual tells you in broken English is to do the corner leveling and the center leveling with the little card, their 0.1 millimeter card, or a normal piece of paper would be fine. We'll go to setting and then level, and then it's got the pre-configured kind of hot points, 1, 2, 3, 4, 5, starting in the center. So with everything hot, with the bed hot, with the nozzle hot, you'll do your normal paper leveling, which we've gone over plenty of times. After that, and this part isn't super clear, on the left here is where you're going to do your Z offset or your probe offset. So that's when the probe hits the bed, how much further up is the nozzle actually from the probe position, right? Because they're not at the same height. So essentially you'll home the Z, which will bring it down relatively close. And then you'll use the down arrow to bring it closer and closer and closer until the paper is perfect drag amount, and then you're good to go. So then you can leave that screen. So if you haven't done that process before, you're not familiar with it, the manual isn't going to help you a ton, mostly because of the lack of instruction, like verbal or not verbal, but written instruction rather than just pictures. The other thing is the auto leveling. When it's auto leveling, it's showing you the hot end temperature as if the hot end temperature is important during auto leveling. Auto leveling has nothing to do with the hot end temperature at all. We're not measuring the nozzle, between the nozzle and the bed like we do with our paper leveling. Temperature matters, things expand. So I'm not sure why they felt it was important to show you the hot end temperature. Not a big problem though. What is strange is every time that it goes to probe, it shuts off the fan. And I don't mean the part cooling fan. I mean the fan on the side here that's actually cooling the heatsink on the cold side of the hot end. If you're running something like PLA and you turned off that fan for any extended period of time, you're going to get heat creep or heat soak, and it's going to soften the filament further up in the heat break and potentially lead to a jam or a clog. So there's really zero reason that I can see why they would want to turn that fan off when they're probing. I know that especially with inductive probes or something that's sensitive to EMI, or electrical interference, they would like turn off the heated bed if it was like an AC heated bed so that it didn't cause that kind of interference. But turning off the hot end fan seems very strange. So there's that. Number 4. Yeah, so this hot end fan again isn't running all the time. Right now it's not running because this is all cold. So it's temperature activated, which we've seen on a lot of other printers. So when it gets above 50 degrees Celsius or so, that fan kicks on and it will remain on typically until the temperature goes below that threshold again, and it would turn itself off. In the case of a print, it's off, temperature rises above that threshold, it turns on, your print happens, and then it just keeps itself on. Again, not a big deal, but I would expect when the temperature goes down after the print that it would just automatically shut off. So you may be able to add G-code into your start script to control that. I didn't play with that. I usually just let the firmware handle that fan, which is typically on when things are hot and off when it's not. So that's something that just seemed kind of peculiar to me. The last thing I found strange is when I was done my prints, I used the screen to power the machine off. And the print had just finished, the hot end was still hot, the bed was still hot. And when I said off, it just turned off the power. So much like I was saying before, you wouldn't want that fan to be off while the hot end is hot. Well, the hot end is 180 degrees at that point, and everything just turned off, fans are off, it's just heat soaking through there. It's gonna be piping hot in just a couple minutes. Just not ideal. If you're going to software control the power on the printer, you should take precautionary measures to make sure that you power it off once it's cooled down to appropriate temperatures to do so. My opinion, I just don't understand why introduce a risk like that. The other, this might just be me being picky, but the other thing is this camera is atrocious. So in the software, you have 2 options essentially. If you want to use your existing slicing process, that's great. You're free to do so. Use Cura, Simplify, whatever you're comfortable with, right? And then you're going to throw it on the SD card and plug it in the front. If you do so, the software allows you essentially no options as far as printing goes. You need to start the print from here and you'll manage the print from here. So that means if you want to adjust the temperature or see the percentage of progress or what have you, you're doing that all through here, not through the app. So through the app, you're going to use their cloud slicing, which I was not at all interested in doing, to be completely honest. If you do use their cloud slicing, then you get all the app features where you are managing the job from here and not from the screen. Okay. So to use the Creality Cloud app, you'll download the app and it will have you just scan this QR code and that will start the setup process. During the setup process, you're going to tell it, if you're using hardwire or if you're using Wi-Fi, and you'll choose what wireless access point or SSID to connect to. Worth noting is it only supports 2.4 gigahertz, but it does support WPA2. So I know on a previous box, I'm not sure if it was Creality's box, one of these cloud boxes, they only supported like WEP and WPA, and that wasn't even an option in our environment. So I had no issues getting it connected. I did not admittedly play with the hardwired connection. I didn't have one where my workbench was. So I used wireless, and honestly, it worked fine. There wasn't really like any latency to speak of. The latency on the camera, image quality aside, was a non-issue either. The app does let you have a nice picture-in-picture window that you can kind of drag around in a small window or make it larger of the video feed from the camera, and the video feed looked like this. So at first I thought, clearly I've done something wrong. There's a protective film on the camera, and there was. So I took the protective film off, and then I turned the camera back on, plugged it back in, and it still looked the same. It was bad. I had a really old Logitech camera I got for free at a conference somewhere, probably $30 camera, and it looked miles beyond this, and it's honestly so bad I don't use that one either. I typically use a C920. So I took that cheap camera and my C920 and tried plugging them both in here, and the app told me that neither was compatible. I need to use a Creality compatible camera. So I'm curious what off-the-shelf cameras we can get that are compatible with this. As of the time of this recording, I haven't reached out to Creality to see if there is any list or at least some specs or codecs that the camera has to support to make it compatible with this machine. So right now, you're stuck with this, and I would probably promptly look for an alternative, especially if I was trying to do anything like time lapse or recording to post it somewhere. Nobody's gonna wanna watch that. So I complained a lot, about the printer. It's nice and quiet, it's sturdy. The UI here worked without issue, aside from the instructions. This was fine. I prefer this to some of the other custom Creality UIs I've seen, like on the Ender 3V2. Wasn't a huge fan. I don't know that the firmware for this is open source. I didn't look into any of that, and I actually didn't play around with any of the firmware on here. I did use the app to update this. So the app told me right away that there was an update for the Creality Cloud box, and you just say go and it does it all through the app and then rebooted the machine or something. It was unclear if that was just their cloud connectivity piece getting a firmware update or if that was actually the board firmware getting updated. I believe it's the former of the two. But it printed. But the printer prints. So the first print is, these three are all off the SD card. They're pre-sliced by Creality. So the first print was this guy, this little bunny. And they're printing at a snail's pace. I'm gonna say 30 millimeters a second. Really, really slow. So you'd expect near, perfect prints. Now I used Creality's own filament, not the sample that came with it. This is Creality branded filament. This is yellow PLA for these. And this bunny on this side was fine, reasonable Z seam up here actually. But on this side, we had tons of under extrusion. The best I can tell is that this is at the beginning of the lines. So whether it's oozing during travels, which the travels were just as slow as the prints, or what was going on there, I have no idea. But they're kind of spaced out, random gaps in the filament. It's not pretty. That didn't occur higher up though, like around the head. We had very, very, very little of that, if any. So I was a little disappointed. I didn't reprint this a second time. I want to say this was like 3 hours or something. And then this printed in less time than that. So this is a vase mode. It's a little bowl. Vase mode prints, as we know, are very easy to get perfect. You're not dealing with ooze or retraction or travels or any of that kind of stuff that can cause issues like we were seeing here if not tuned correctly. What I did notice is the base of this guy, it seemed like we were actually too close. So when you end up with those wavy little lines in the bottom, you're typically too close to the bed, but it wasn't consistent. So along the edges, we weren't too close, and in the center we were. It does do a mesh probing of the bed. Ideally, I'd like to see UBL. UBL should be the best of both worlds. So it's building I think it was a 4x4 mesh. So it's got 16 data points to deal with as far as the topography goes. So I shouldn't have seen like a big area that was too high or too low, because it should be dividing that into smaller squares and then even further extrapolating that. So, we're a little close, ultimately, in the center of the bed. Then this little guy with a tiny, tiny base stuck perfectly well. I'm happy to see that Creality is not slicing their stuff with rafts or anything anymore. This guy printed, again, 3 hours or so. Again, it's a vase mode print. Turned out absolutely perfect. And then I decided, since these two turned out well, and this was someone else's slice, so I'm gonna chalk up the issues to them, I printed this. I used a profile that I have in Cura that is actually for a Hemera that I've used for multiple years now. And I figured this hot end is close enough in design, function, filament, travel path, etc. Same size nozzle that I'm using. So I use this same profile. I did slow it down than I normally do on my machines. I slowed it down to 60 millimeters a second, and this print took 24 or 26 hours. It's definitely not solid, it's hollow, it's supposed to be a pineapple, and to be frank, it turned out terrible. So there's a couple things. One, I've never printed this before. And when you're previewing an STL, sometimes some of the facets have like artifacts almost in them. There's a little bit of that going on, but I didn't see that consistently reproduced in the print. So I think that was just the preview looking a little strange. I did notice, and it's gonna be very hard to pick up here, some of the defects are easy. I did notice a little bit of ringing on one of the sides, but only one of the sides. Stupid me, I didn't mark the print before I pulled it off the bed, so I can't actually identify if it was the back Y, the front Y, or left or right X, right? Because that would definitely help. At least knowing that if it was on an X face, that it could be the tightness of this belt, or the belt's too loose, causing kind of floppiness at the edges as it stops directions from side to side. But I'll have to print something else and try to see if I can reproduce that. What is immediately apparent though, aside from the general ugliness of this print, here's the area. So what is immediately apparent is the banding type issues that we have. And I say banding type because it's not Z banding. Z banding you will see at a regular interval, right? Because if you've got like a bent Z rod, every time that comes around, you're gonna have an artifact introduced into it. This is not consistent. It doesn't appear in the top of the print, only the bottom, and only in a couple areas. So hopefully this picks up on camera. Down here you can see a couple of the different color variations on this band. This guy. So down here you can see a couple of these color variations on this band. The bands also don't line up with the top surface here, which could happen, as you're bridging a sparse infill. You might over extrude, or you might have inconsistencies there, and it can result in a kind of a ridge on the outside of the print. It doesn't line up with that. It's kind of in the middle of the infill, and there's 1, 2, 3, 4 of them. This bottom one here is much, much more subtle than the rest, but regardless, 1, 2, 3, this is garbage. This is going to be a Christmas present, pineapple with a top and everything for a friend. This will now, unfortunately, go in the garbage. And being that it's large, it's quite a bit of filament. I think it's probably 200 grams or so. But as far as like the top layers, very, very smooth, great top layers for sure. There was a lot of zitting at the begin and end points of the lines. I don't have that in my prints on the other printer with the Hemera. So obviously it's not fair to just take a profile from one and slap it on the other, but it should have been close enough. And I'm printing this at a low temperature for that filament at 200. So it shouldn't have had like a whole lot of stringiness or ooziness to contend with. So I will need to, spend a more typical amount of time fine-tuning the printer, trying to reproduce this banding issue, and make sure that I've got whatever is causing this zits under control. Regardless of my flaws, out of the gate, I would expect factories to have prints that turn out flawless. At least, to be the best representation of what the printer is capable of, and these don't do it for me. As I said, vase mode, it's easy to get, very good. A regular print, much more difficult, and there's a lot of room for improvement there. It's better than mine, in my opinion, so they've got that going for them. Hopefully you found all this useful. Remember, like and subscribe, and ring the bell to get notified when we upload more content like this.